Metabolism is the protective biochemical process by which our bodies alter xenobiotic either enzymatically or non-enzymatically. Generally, drug metabolism begins with a hydrophobic drug and converts it to a more hydrophilic metabolite to facilitate its elimination. An understanding of the drug metabolism process and the potential outcomes is critical for developing safe and useful pharmaceuticals. Drug metabolism can result in one of two products: an active metabolite or an inactive metabolite. Inactive metabolites of the drugs basically have no pharmacological activity of the original drug. An example of that would be the hydrolysis of procaine into para-aminobenzoic acid and diethylethanolamine, which results in the loss of anesthetic activity of procaine. On the other hand, an active metabolite can mean that the metabolite can retain the same activity as the parent drug. That's apparent when codeine is demethylated to a more active drug, which is morphine. However, in some cases we notice a result known as bioactivation, where the parent drug is inactive and the metabolite would have a pharmacological activity. In this case, the inactive parent drug is called a prodrug. An example of a prodrug is enalapril, which has no activity as an antihypertensive agent. But upon hydrolysis, it becomes enalaprilat, which is a potent antihypertensive drug. Bioactivation of a drug can also lead to a toxic metabolite. The widely used acetaminophen has a metabolite that is called N-acetyl p-benzoquinoneimine, which is hepatotoxic. I have explained the mechanism of toxicity and the antidote in my previous video, which I linked in the description below. The liver has the highest concentration of drug metabolizing enzymes because of its location between the gastrointestinal tract and the systemic circulation. Based on the reactions involved in the metabolism process, we can classify the metabolic pathways into phase 1 metabolism and phase 2. Phase 1 metabolism is characterized as a functionalization reaction, where they add or reveal a functional group by oxidation, reduction, or hydrolysis, hence leading to an increase in overall polarity of the drug, which facilitates its excretion in the urine. Oxidation is the most common phase 1 reaction. Cytochrome P450 is a superfamily of oxidases that are responsible for the majority of oxidation reactions. It's found in very high concentrations in the liver. Oxidation can also happen through alcohol dehydrogenase, which is an enzyme that oxidizes alcohol into aldehydes from primary alcohols and to ketones from secondary. Aldehydes can be oxidized from carboxylic acid by the enzyme aldehyde dehydrogenase. We can see that in the example of conversion of acetaldehyde to acetic acid in the metabolism of ethanol. Another phase 1 reaction is the reduction reaction. There are several reductase enzymes. Common reduction reactions include the reduction of disulfide bonds, in which disulfides would be reduced to free sulfhydryls. Another reduction reaction is done by aldoketoreductases, which reduce carbonyl-containing compounds back to alcohol in a process opposite to the oxidation done by alcohol dehydrogenase. The last type of phase 1 metabolism reaction is hydrolysis. Hydrolysis is basically the addition of water across a bond, resulting in a more water-soluble metabolite. A great example of that is ester hydrolysis, which is performed by the enzyme esterase, found throughout the body. Esterase is the responsible enzyme for the hydrolysis of an ester into a more soluble alcohol or carboxylic acid. Now that we have an idea about phase 1 metabolism reactions, we can start explaining the phase 2 reactions. Phase 2 reactions are commonly called conjugation reactions, owing to the fact that they add a functional group on the drug for the purpose of increasing its polarity. The conjugation process requires an enzyme, generally termed as transferase, that transfers the large polar molecule, called a cofactor, onto the drug. There are a lot of examples on phase 2 metabolism reactions, of which we will mention the most common. First example would be glucuronidation. Glucuronidation is the most common phase 2 reaction. Glucuronyl transferase is the enzyme that uses UDPGA as a cofactor to transfer glucuronic acid to several functional groups, like hydroxyl, carboxylic acid, and hydroxylamines. The glucuronic acid adds a significant amount of hydrophilicity to the molecule, facilitating its excretion process. Another popular reaction is glutathione conjugation, which results from the addition of glutathione molecule to an electrophilic substrate. Being a nucleophile, glutathione generally acts to detoxify the electrophiles. Glutathione S-transferase is the enzyme responsible for the reaction of glutathione with electrophiles, like epoxides and halides. After the conjugation, the product is excreted as mercapturic acid in the urine. Thank you guys so much for watching the video. If you liked the video, make sure to like it, subscribe, and tell me your suggestions for any future videos. And see you next time.